All right, let's start at the basics. That seems like a good place as any to begin this. We're going to start with the math involved to do ultrasound. And all of the math, it's nothing difficult. It's just simply relational mathematics. And by relational, I mean if the frequency increases, what happens to, let's say, the period? Or if we increase our wavelength, what happens to the frequency? So these are different aspects of sound that we're going to be talking about later, but the math is just simply relational. If I change A, what happens to B? And so we have A and B, of course, are variables. And so let's just talk about what variables are. Variables are things that can change. Okay, you can have unrelated variables where X is not related to Y, and so things like that is the temperature outside is not related to what day of the week it is. We've all had cold Sundays and we've all had hot Sundays, so we know that the temperature and the day of the week have nothing to do with each other. Hair color is not related to your weight. It may change as you get older, but a person who weighs 143 pounds is not a redhead, and redheads are not necessarily all 112 pounds or whatever they may be. They vary. So these are variables that are not related to each other. Directly related variables are things that directly change. So your skill at something directly changes with the amount of practice you put into it. Your clothing size is related to your weight. Other things that increase is the amount of money you make is related to how many hours a week you work if you're an hourly employee. So those are things that are directly related. There's other types of variables that are inversely related. So as one variable goes up, the other one decreases. So your grades will decrease as you increase the amount of time you spend at parties. Your spending will decrease. Your money will decrease if your spending increases. So those are inversely related variables. It's not necessarily true that your money will increase as your spending decreases, but it often is. Okay, reciprocal relations are two factors that multiplied together are going to result in one. So the easy examples are 2 and a half. Those multiplied together equals 1. 10 and 1/10 equals 1. When we get into ultrasound, we start talking about things that multiply together, such as seconds and hertz. Hertz is a measure of frequency. So seconds and frequency multiplied together equals 1. The period is a measure in seconds, and the frequency. You multiply those together, you end up with 1. So those are reciprocal relationships. The period of a wavelength is the reciprocal of the frequency of the wavelength. So you can see now how these can be reciprocals. If you multiply the period times the frequency, you're going to end up with 1. All right. So relational math is always just looking at different things and seeing how they relate to one another. In our example here, I is proportional to P. As P increases, I increases. I is inversely proportional, is inversely related to A. As A increases, I will decrease. I is inversely related to the square of R. So as R increases, I decreases by double or by the square. So it's inversely related, and R is squared, so that's going to give us a inverse and exponential relationship. So here's another example. If we double the frequency, what happens to the wavelength? Well, if you double the frequency, the wavelength has to change and it decreases. So these are related. Frequency and wavelength are related, and you have to know how it would change. So if we double the frequency, the wavelength reduces by 1/2. That is the mathematical relationship between frequency and wavelength. So what are the units that we use when we talk about ultrasound physics? Well, everything has length, so we utilize the length of meters. If we want to look at an area, we're going to use a measure of meters squared or centimeters squared. In these examples, the brackets show you the unit symbol that we utilize for the measure. Usually we drop the brackets when writing out a unit. So if we write out 2 centimeters squared, we don't put the brackets around the centimeter squared, but actually it's proper to do that. 45 degrees Celsius, we could put the brackets around the degrees Celsius. 140 meters per second, the unit is meters per second, and that could be in a bracket. But we always drop it when we're just writing it out. Units can be multiplied or divided to combine things, but they can't be added together unless they're this exact same type of unit. Okay, so if you work 40 hours a week, you can state that you work 40 hours per week and you combine the units. However, it makes no sense to say you work 40 hours plus you eat 3 pizzas. That is not 43 pizza hours. It's just senseless. So we can't combine units when adding unless the unit is the same. So we have to have similar units to add, but multiplying and dividing, we can multiply and divide our units. It's no problem. So 2 centimeters times 5 seconds is 10 centimeter seconds. Yes, that works. 2 centimeters times 2 centimeters squared is 4 centimeters cubed. Yes, that works. 2 centimeters plus 5 seconds does not equal 10 centimeter seconds. It just doesn't work. And 2 centimeters plus 2 centimeters certainly equals 4 centimeters. So here we have an example of similar units, so we can just add them together. Sometimes we have to change units. We have to convert units. So units have to be the same type. And so if we have days, that's a type of time. And we know that how many days are in a month. So generally about 30 days. So we can convert days to months if we know what month it is. We can also convert pennies to $1. So there's 100 pennies to $1. So $1 equals 100 pennies. Those are identical. Okay. In ultrasound, we might have to convert 1540 meters per second to kilometers per second. So we have to find out how to do that. How about if we need to convert 3 megahertz to hertz? Okay, we have to be able to do that. So how do we do that kind of conversion? Well, what you do is you treat the units as fractions with a value of 1 and carry the units. So you have 12 donuts in 1 dozen. So how many donuts do you have in 4 dozen? Well, that's easy. You can see that we have a reciprocal here of 1 over 1 dozen times 4 dozen. Okay, the dozens will cancel. So that's what we mean by treat the units as fractions with a value of 1. Dozen over dozen will cancel. So we have 12 donuts times 4 equals 48 donuts with the 2 dozens canceling. In the metric system, we have a really unique thing going on with these numbers. So we have measures that can be either applied to length, time, or volume or anything. So gigameters, gigahertz, megahertz, kilograms, those are all different uses of the prefix with a type of measure. And particular are these ones that are connected here. 10 to the 3, which is kilo, or we just abbreviated K, which means 1,000, is related to 10 to the minus 3, or millis, or thousands, as reciprocals. Okay, and so that's going to be important. Whenever you're dealing with metric system and reciprocals, you want to remember this relation between mega and micro, kilo and milli, and giga and nano. There's some others, hecto and centi, but we don't usually get into that one. So if you remember that relationship, it'll come in handy when we start doing reciprocals, and we'll show you in just a little bit. So the metric system is based on powers of 10. Almost anybody in the United States that speaks 2 languages inherently understands the metric system. Those that are monoglots or only speak English tend to have a little bit of trouble with the metric system, but you can remember that it's in powers of 10, and it utilizes scientific notation and units to handle very large or small amounts. And so scientific notation is just simply a number times the unit. Remember, here is mega, which is equal to 10 to the 6. And so we can have 1,000,000 equals 1 times 10 to the 6, or 1,000,000. 1,000 meters is equal to 1 kilometer. We've replaced the 10 to the 3 with K, and so now we have 1 kilometer. Megahertz is 1,000,000 hertz, and so it's equal to 1 times 10 to the 6 hertz, which equals 1 megahertz. So with metric units, we often relate physical properties by utilizing reciprocals. And so if the frequency equals 1 megahertz, then the period is 1 over 1 megahertz, or we simply can write 1 microhertz. Remember, mega and micro, in our little chart that we had here, are reciprocals of each other. So when we go to do this relationship, whatever's in the bottom here, we raise to the top and change it to the reciprocal. So if the pulse repetition frequency is 4 kilohertz, what is the pulse repetition period? And I'll leave that for you to figure out. And we'll pick it up in chapter 2.